All right, welcome back. We're going to proceed with problem number 3. It says consider the region bounded by the curves 2x equals y cubed, y squared rather, and x equals 2y. So make a sketch of the two curves on the same axis, determine the points of intersection, and determine the volume of the solid that results when the region enclosed is revolved around the y-axis. The y-axis? What jerk wrote this problem? Oh, never mind. So here we go. All right, so we have 2x is equal to y. All right, and we have x is equal to 2y. All right, nice. Thanks for, oh, wait, equals y squared, right? Equals y squared. Yeah. Yeah, thanks for being consistent with the x's here. So here we have y is equal to, x is equal to y squared over 2, x is equal to 2. Y. So I'm just going to equate the two of them, right, to see where they intersect. Like that should be where the two curves are equal. So we're going to do something clever, like y squared over 2 is equal to 2y. Multiply both sides by 2. So we have y squared is equal to 4y. And then what we're going to do is say y squared minus 4y. It's always better to try to subtract these from try to divide, because if you divide, you lose information. If you subtract, you maintain it. So that's y minus 4 is equal to 0. So we have y equals 0, y equals 4. Well, if y is equal to 4, okay, you can plug this into either of these two, right? You're going to get 16 over 2, which is 8 for x, or you're going to get 2 times 4, which is 8 for x. So either way, all right, take whichever one is you find easier to deal with. All right. Now, I don't know, like which one's further to the right, which one's further to the left. I have no idea. Okay. So I know they intersect at the point 8, 4 and 0, 0. Like, great. Could I pick any other point and see like which one is bigger than the other one? Okay. So what if we set y equal to 1? What's my x, right? If we have y is equal to 1, then we have x is equal to 1 over 2, okay? Or x is equal to 2. Okay, so I think the y over 2 should be further to the right. So let's go ahead and graph that. All right. So 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4. So we're here. Okay. And there, it's a little bit easier if you're dealing with this as a paper rather than a board like this. But what we're going to have here, something like this, and we're going to do something like that. Okay, so it's going to be this guy minus that guy, and we're revolving around the y-axis. Okay, it's not as bad as it seems. So if I pull my slivers like this, okay, we're going to add all of these guys up, right? Then these are dy's, right? And we're pretty much using the cylinder method, right, or washer method. So we're going to say that our volume is equal to pi 0 to 4. We've got the outside one, that was what? The outside one, which was 2y squared, because it's a radius, right? Radius squared minus radius squared, minus y squared over 2 squared dy. All right, so we have to deal with all of this. Okay, this is washer. All right, so okay, it's once you have this set up, and I really want to see a drawing like this from you guys, because you're going to be doing this with computers, you're going to be doing this with everything else. The idea of how to set it up is kind of the important thing. As far as the engineers go, they want to see like what happened. How did we do this? Okay, so volume is equal to pi. And let's go ahead and deal with the squares. So that's going to be what? It's going to be 4y squared. And if I square that, that's going to be y to the 4th over 4, I think. Am I looking at this right? Yes, I am. Yep, dy. All right. And again, we're going from 0 to 4. Okay, now we have to integrate this. Not really as bad as it looks, right? So this is pi. Integrating this is going to be 4 over 3 y cubed minus 1/4 times y to the 5 over y to the 5th over 5. And we're going to be going from 0 to 4. If I plug in 0 here, you guys see that that's going to be 0. We don't have to worry about that part. So we're just going to deal with the 4 here. There's no cosines or anything like that in here, so don't have to worry about it. So we have v is equal to, and now the fun part happens, right? Now we get arithmetic. So this is 4/3 times 4 cubed minus 4 times 5 is 1/20. And we have 4 to the 5th here. Okay. So really, it looks like we have v is equal to pi 4 times 4 cubed. Isn't that 4 to the 4th? Over 3 minus 4 to the 5th over 20. Sure that is a delightful number. Okay. It looks like you can take a 4 to the 4th out. Times pi. And I have 1/3 minus 4/20, which is a 5th. Okay. Why are you doing this? I'll show you. Let's go ahead and take out, like, what's 1/3 minus a 5th? Okay. 1/3 minus 1/5. Okay. Second. Well, no, not second, just math. Math it, turn it back into a fraction, and that's 2/15. So we have 2/15 times 4 to the 4th times pi. What is 4 to the 4th? 2 times 4 caret 4. 512 over 15 times pi. There's our answer. But you might say, wait a minute. I don't like dealing with y's, and I didn't like the cylinder method too much. I didn't like the washer method. I like the shell method. Okay, let me be the first to tell you that you're kind of weird, but that's cool. We can do it that way too. Okay, what if we try the shell method? Right, so yeah, you kind of got to know both. I might even be so devious as to put a problem like on there that says do it both ways. That way you know you're going to get the answer correct. It's more about the setup than it is about anything else. Okay, so shell method, right? That was 2 pi times r times the height, and then there was a tiny amount in here, right? That was the big R minus the little r. That was my delta. Okay, so let's go back to drawing it. So in this case, right, we've got what do we have? Yeah, you can go away with that. We had y squared equals 2x. So we have y squared is equal to 2x. So y is equal to the square root of 2x. That's plus or minus, right? But we'll take the plus one because we know when they're in the first quadrant. We also had 2y is equal to x. So we're going to say y is equal to x over 2. And I'm going to sneeze here, so apologize for that. The same drawing. Okay, it's going to be exactly the same drawing. So we had our line, and then we had our square root function here. We're still running around this axis, but instead, right, we're going to add up all of these shells. Okay. Now my radius, what's my radius? That's x. And my height is going to be the big function minus the little function. Okay, so the height is going to be the square root of 2x minus x over 2. Okay, and again, my d, right, my dx here, that was the big radius minus the little radius. That's how we put this thing all together at the beginning. Okay, but instead of our y's, we're going from 0 to 8. Okay, so we have 2 pi, right, because it's 2 pi r h delta x. okay, or delta R. Okay, so we have from 0 to 8. I'll just change that delta R. So my radius, x, my h, okay, that's going to be square root of 2 times x to the 1/2, right? I want to turn it into a calculus problem as soon as I can. Minus x over 2 dx. Like, why did I have to separate the r squareds before? It's because they grow as a squared. This is a linear term, right? It's just, there's no power out here. So there's no weirdness going on with intermediate terms or anything like that. So we could just subtract them. Okay. And what we're going to do, okay, multiply by that x. So we're going to have square root of 2. We have x to the 3/2 minus x squared over 2, right? We haven't integrated yet, so we're still doing that. So we've got that set up. Now we're going to integrate. So this is going to be 2 pi. Oops, we're integrating. We are not doing that. So this is going to be square root of 2, x to the 5/2. Be careful with that. Okay, that's always a place where students kind of mess up a little bit. Calc 1 more than Calc 2, you guys are pretty good, but you never know, right? Make sure you're adding 2 over 2 for year 1. Okay, minus, and we have x cubed over 1/2 times 1/3 is a 6th, right? Okay, we're going from 0 to 8. All right, so let's see here. We've got 2 pi, and again, if I put in 0, we get 0. So we're just going to worry about the 8 here and do some fancy arithmetic here. So that's square root of 2 times 2 times, that's this 2, okay, times 8 to the 5/2 all over 5, okay, minus 8 cubed over 6, right? Well, 8 to the 5/2, right, is equal to 8 to the 4/2 times 8 to the 1/2, right? When the bases are the same, we can add the exponents. 2/2, that's going to be 2. And 8/2, right, 8 to the 1/2, that's equal to 2 root 2. Okay, because it's 4 times 2, and the square root of 4 is 2. So we get 2 root 2. Hey, there's a square root of 2 times 2 right here. So this is 2 pi. This is the square root of 8 times, now we get 8 squared times the square root of 8, right? 8 to the 1/2, square root of 8. Okay, all divided by 5, minus 8 cubed over 6. What do you figure 8 squared times the square root of 8 times the square root of 8 is? That would be 8 cubed over 5 minus 8 cubed over 6, 2 pi. Okay, so here we go. We have 2 pi, 8 cubed, times a 5th minus a 6th. We could do that, right? So that's going to be 6/5, 6/30 rather, minus 5/30. So that's 1 over 30th, 8 cubed, 2 pi. 2 by 30, that's going to be pi over 15 times 8 cubed, which 8 cubed is going to be, what, 512 or something? 8, oops. 8 cubed. Hey, what do you know about that? So 512 pi over 15. Didn't matter how we did it. We got the same answer both ways. You gotta really appreciate a problem that does that for you. Okay. So generally, I'd probably let you guys choose which method you wanted to do. And I'm open to put some formulas down. I'm not going to put a lot, but there'll be some formulas I can provide. So if you really, if you're doing this and like, I don't remember either of these, I'd be inclined to include some. So if you're going through your final, or you're going through the practice final, and you'd really like to see a particular formula, there's some I can add. Okay, so let me know, and I'm going to stop talking and go to the next one.